push that rock here with Simpson math. Here's a simple differentiation rule. You might want to put that in your notes. The derivative of natural log is 1 over x. Let's justify it. Let's remember that the definition of a log here, log base b of x is equal to y if and only if b to the y equals x. Of course, this is for positive values of b only, and also b is not 1. We'll use that to help us justify that simple rule. Our rule was dealing with the natural log of x, so we'll write down this for the natural log of x. And we have the natural log of x equals y if and only if e to the y equals x. Now what we want to do is deal with this. So I have e to the y equals x, and I'm going to implicitly differentiate. I'm going to take the derivative with respect to x on both sides. And taking the derivative with respect to x of x, we get 1. Over here we get chain rule, we give birth to the mother. So give birth to the mother, but there's some function stuck inside there, so we have to multiply by the derivative of that function. That's the chain rule. So we have the derivative of the outside function with the inside function put in it times the derivative of the inside function. That's chain rule. Now I just want to get dy dx by itself. So I get dy dx is equal to 1 over e to the y. But remember, e to the y is x. Okay, so we have dy dx is equal to 1 over, substitute in x for the e to the y, x. Now remember, all of this came from where? Where did this come from? It came from, the natural log of x equals y. So I took the derivative of this y, derivative of that y with respect to x, and I got 1 over x. So that justifies the rule that the natural log of x, when you take the derivative of it, gives you 1 over x. Now, we don't really want to memorize this simplistic little rule, because there's a more powerful one using the chain rule. And the more powerful one I refer to as, if I can turn the page, I should have prepared this better. Sorry. This more powerful rule I call the vanishing log rule. So if I'm taking the derivative of the natural log of some function, I just get that function in the denominator and the derivative of that function in the numerator, and this is called the vanishing log rule because the log vanished. There's no log over here. Now this is quite easy to think about. Just imagine the function is a natural log of x and g got put into it. So the inside function, you know what? I have it. Let's switch from f to g as the inside function. So we'll kill that. We'll go here. I had this planned and I forgot. So we're going to say y is equal to the natural log, and we're going to have g put into it. So f is the natural log of x. G is the function that got put in. We'll take the derivative of natural log of x. We just showed that that's 1 over x. But remember, you need f prime evaluated at g. So I put the inside function in there. I get 1 over g. And then the derivative of g is just the derivative of g. And so then the derivative of this would be 1 over g times g prime, which of course is g prime over g. Now, my inside function over here is f. So just applying the same rule, you get this. And this is called the vanishing log rule. And it's very useful and very common, and you need to definitely know that rule. Math made simple. Simpson math.